Hello and thank you for subscribing to Infoverse Tech. Today we're going to look at a very interesting tool that is native in Linux, and it's called the Linux TR command, or for transform. So we're going to look at some examples and show you how powerful this command is. So I'm just heading out to the man page for TR, and you can see that it stands for translate or delete characters. And the basic syntax is the tr command followed by set1 and set2, and sets are actually strings of characters, so that's how we categorize them. And then there are some commands that you need to learn, like dash d for delete, dash s for squeeze, dash t for truncate, and so on. And then some additional switches that we can provide to the command to execute and get the output that we desire. So let's head over to my Linux server that's running, and this is what I've been using for these YouTube tutorials, especially on the Linux command line side. So it's just CentOS 7 running in VM player, and I have an SSH into that Linux box. So let's get started. The first command I want to show you is just to how to get started, and it's let me show you the syntax. So let's say, as an example, I have this line which says echo in curly brackets hello Infoverse, and then I'm going to pipe it. So pipe means in Unix that you're sending the output of the echo into as an input to the tr command, and tr is the Linux transform command. And what we're doing here is, this is the first set, so we are looking for curly brackets, and then the second set is the replacement. So we are replacing the curly brackets with the round brackets, right? The standard brackets. So let's run this and see the output. So as you can see, the curly brackets were converted. So they're very simple examples, but what we're going to do is we are starting with simple examples and then build up, and finally I'm going to show you some possibly real use cases of using the Linux tr command. Let's look at another example where we have some extra space in the text and we want to reduce that. So you can see that in this sentence there are a lot of extra space. So we're going to use we're going to pipe it through tr, and then we're going to use the dash s, which means to squeeze or to reduce, and then we're going to look at this extra space given by these apostrophes. So let's run that, and as you can see, the output command is welcome to Infoverse Tech Canada, and all the extra spaces are gone. So again, a very simple use of dash s to get that output. Now let's look at another simpler. Maybe this doesn't have real world use, but all we're doing is that we are removing the first character and we are matching it to capital W in this text. So when we run that, as you can see, it just matched W, and the dash D means delete, so it removed that. Like I said, it's not very applicable to a real world use case, but just to show you the use of D. But definitely we will be using D in a few other use cases later on. Let's look at another example. We want to completely remove all the digits in a certain text, as an example. So here we are saying echo my user ID is some numbers, and I'm piping it through tr, and then I'm deleting, and as you can see, I have we are introducing something new, which is digits. So this means all the digits. So the command reads remove all the digits from this piece of text or piece of string, and we have this format to say, square brackets, colon, digit, and then close. So let's run that, and you can see that it removed the digits. Let's run this in a different manner, and let's say we want to extract all the IDs. So I want to extract the user ID for some user running on my system. So in that case, what I'm going to do is I'm going to use an interesting flag called C, or complement. So it reverses the logic. So instead of removing all the digits, we are removing everything except the digits, right? They're just an inverse of the previous command. And I just want to make it more readable by adding a new line. So, and we just enclose this in apostrophes, and let's run that. And as you can see, it extracted that ID that we were looking for, and very cleanly represents it here. So again, very good use of the -D and -C, which like I said, inverse the logic, and you have a new functionality. Now let's look at another way of using this one. So instead of digit, I could say 0-9, and let's run that. So again, this also means all the digits including 0 to 9. So again, you see that it deleted it, but we want that real use case where I just want to extract that ID for my user, and when we give it 0-9, meaning include all the digits from 0 to 9, and run that, as you can see, it gave the same result. So this one is the same as this one which we ran earlier, but I just wanted to show you that this is another way of using it. So instead of using digit, you can say 0-9. Okay, let's go to another direction, another example, and here we want to introduce something called redirection. So, and for users of Linux, this should be familiar to them, and the idea is to be able to read from a file, right? So here what we're doing is we have the tr command, we have a lower, so set1 is lower, translate it into upper, and read the file called lower to upper, right? So this incoming arrow means I'm reading from it. Let's quickly show you. So we are in this tr-command folder, and I have some files here which I've set up for this tutorial. So let's look at the one that says lower to. So let's just look into it, the contents there, and you can see that this is all in lowercase. Now let's run that command again, and let's run that. So as you can see, the tr command has set1, which is lower, set2, which is upper, and it's reading from lower to upper.txt, and the output is hello, this is a test of converting lower to uppercase, and we now have all this full sentence is now uppercase. Now let's look at another example. Now this is printing to the console. Maybe we want to save this output now that it's uppercase into another file. So we can use another redirection, which is writing out, and we can say output.txt, and when we run that, we don't see anything displayed on the console, but it's been written to the output.txt file. So this is a very good example of redirection. We are reading in, and then we are also writing out within the same command. So let's quickly look into the contents of this new file that we just created, and as you can see, this is exactly the same that we saw on the console, except that it's been written to the file directly, and that file, if not there already, it would be created. So very handy way of manipulating these characters. Let's look at another example where what we want to do is we have this text, and it says tr is and you can see it's got a bunch of punctuation and other characters. So we want to pipe it through tr, and let's ignore the -c for a minute, but we are saying it that all the characters, lowercase characters A to Z, translate them into space, and when we add the -c, that means the reverse of that, right? So when we run this, as you can see, the tr is a good. So what it did was it retained all the alphabets, but removed the what else was there, right? Which was the punctuation marks. If we run this without the -c, let's see what is the output, and you can see it just prints out the punctuations. So let's look at another one, and here we can replace this. We have something similar called, like we used the digit earlier on, we have something called punch, right, for punctuation. And when we run this, it does the same job, that it translates all the punctuation into space. So you can see that all that cleaned up. So this can be considered a real world use case, because we just cleaned up some text that was given to us. Now let's look at some other examples that might be a little more real world. So let's look at another example. Let me just bring it here. You can see it's a little messy. It's got some repeating characters. So what we're going to do is we're sending that into tr, and we're using the -s, which, if you recall, it was for squeeze, and we are saying all the capitals A to Z, translate them into A to Z, and also make them unique. So let's run that, and you can see that we actually performed 2 tasks. So we got rid of the repeating characters, and we also made it small case at the same time. Let's look at another example. So this is more real world. So when we're traveling to I'm based out of Canada. Whenever I travel to US, in Canada you have an alphanumeric postal code, but US has a 5-digit postal code, right? Or they call it zip code. So when you're using your credit card, you need to somehow use the right you need to map your postal code, which is 6 characters in Canada, to 5 digits in US. So how do you do that? So let's take an example. So as you can see, in Canada you have a 6 character, which is a mix of alphanumeric, so it's a mix of alphabets and digits. And US expects, when you're entering the zip code, it expects a 5-digit, all-digit zip code. So what this is going to do is, we're just inserting a we're just saying, we don't want a new line. So here we're echoing convert Canada postal code L9T 6M5, some random postal code, to US when traveling in US. So we pipe it through TR, and then we remove the alphanumeric characters, and then we pipe it through blanks. So this will remove any blanks, and then we also need to pad it with 2 zeros. So let's run that, and I'll explain how that works. So as you can see, this particular postal code will translate into 96500, and if you use this is this should be valid. Let's take another example, and let's go back here, and let's change this to another. Okay, this I believe is somewhere in Mississauga, but let's try this. So same, I didn't change anything except I changed the postal code. So let's say you live in this area, you get this postal code which has to match your credit card. So what do you use when you're traveling in US? So let's run that, and you can see for you while you're there, this should be the zip code that you can use, and which maps to this. So an interesting example, and something that has real world applications. Let's look at another example where what we want to do is to find out if a certain MAC address is valid, right? So how do we do that? We know that a MAC address consists of 48 bits. It usually represented as a string of 12 hexadecimal digits, 0 to 9, A to F, or capital A to F, right? These are the digits comprising of a MAC address, and this is what you typically find. This is what a MAC address looks like. So what we're doing here is we are echoing that MAC address, we are piping it through TR, and we are saying, so this is a special we learned the use of digit, and for hexadecimal we need to use X digit. So what we are saying is we delete all the hexadecimal characters, and with the -C means to do the opposite. So let's run that, and let's run that without, I don't need that right now. So let's run that, and you can see that it repeated some characters. So it matched all the characters that are valid for a MAC address. Now let's run that through a word count, and it gives us 12, which means it's valid, right? Now let's see that I am trying to, or I have a wrong one, right? So I'm using a character that is not part of the MAC address definition. So let's say like a Z, and when we run that, you can see that I get an 11, right? So it doesn't match. It should have been 12. That's what the total size of the MAC address is. So there's definitely something is wrong, and this is not our correct MAC address, right? So it's a very simple example to help explain how you can use X digit. I'm sure we can modify this command and be able to even do lookup. As you know, the first three of these bits can be used to actually match to an organization that has that MAC or owns that MAC address. As an example, the 6C, I'll just write this here. So these, if you see these in a MAC address, this means it's owned by IBM Corporation, right? As an example. So certainly this command can be combined with others to be able to match a list of your corporations and say, okay, this matches to this XYZ corporation. But here I just wanted to show you a very quick test to see if the MAC address that you're working with is valid or it's not. Okay, let's look at another one. Maybe this is a simpler one, which is to just remove some extra. So we have some repeating characters, and when we go ahead and run this, you can see that it removed and just keeps the unique ones. And again, this is similar to what we know about using the unique command in Unix. Okay, let's look at another one. This is a little more interesting one and can have it's a real world use case. So let's run that. So what we're doing is echoing Linux TR command can also be used as an encryption tool. That's interesting. We're piping it through TR. So we're saying we have A to Z. We translate that into D dash zabc, and we write that into secret.txt. So before I write that, let me just show you, or let's do that. So basically what we're doing is that we are translating all the characters A to Z with something that's starting with D, then dash, and then the range is starting from D, then it goes to Z, and then we have ABC. So when we run this, and we have written that in secret.txt, let's look at what we wrote. So as you can see, it's using what's called a very popular Caesar encryption method, where you offset the characters by 2, 3, 4, and then you just encode that accordingly. So not a very strong encryption, but it's just for showing you how the tr command can be used to. And interestingly, we can now reverse this to decrypt it as well. So let me just show you how to do that, and we can decrypt this. So to do that, what we do is we have the same mapping, so starting with D to Z and then the ABC, and we are actually the redirection, which is we are reading in the secret.txt, the text that we just encrypted. So when we run that, as you can see, it's able to decrypt it and show you the exact the original. So very simple idea, but it's some basic form of encryption that you can do with the tr command. Let's look at some like log processing. You're getting interested in getting the UID from the text, so let's run that. I have this command, so echo my ID is 1234986. We run it through tr, and again we're using the digit designation, and we are saying remove all the digits, delete, but then we're saying doing the opposite of that. So when we run this, what we'll get is we'll have a clean extract of the UID. So again, this is a world, a use case from the real world. Okay, let's look at another example where we have a paragraph and we want to, so let's have a look. So I have some paragraph dot text. Let's take a look at what's inside. So we have a paragraph, it's got some text in it. So we want to do is read that paragraph, break it down into separate lines perhaps, and then display that. So when we do that, let's see, so we are reading in that some underscore paragraph dot text, and then we are piping it through tr, and we are saying all the punctuations, remove those and insert the line number. So as you can see, this is more readable, that text that's in some underscore paragraph dot text. And something to note that since we're using redirection to read, you're not making any changes. If I show you the some paragraph again, that file should stay unchanged, right? It's the same file. So all we're doing is when we're running this command, it just displays that output, which is more readable here. We can certainly use like a redirection to write it to another, let's say out.txt file or somewhere, and it will write that out, right? If we cat that, you see that the same thing, instead of on the console, it's written here. Okay, let's look at some couple of other examples, and then we can wrap up. Like I said, this is a very simple tutorial to TR, but I'm sure you will find it useful and hopefully can use it in your put it some good use. Let's have another example of extracting, let's say, a customer ID from a database. So I have a file called, sorry about that, I have a file called consumer Okay, let's see. Oh, sorry, it was customer.csv. So some a typical file, name, country, social security, title, and you have a bunch of employees with their title and their ID. So what we're interested in is extracting, as an example, their employee IDs. So how do we achieve that? We run this command. So echo employee IDs, and you're saying, you're running another command with that, chaining that, and saying cat read from customer.csv, this file that we just looked at, and run it through tr-cd. So let's ignore C for a second and say we want to delete all the digits, and then we're saying -c, which means the inverse of that. So when we run this command, all we're going to do is extract the employee IDs, as you can see here. And again, this is displaying on the console. Nothing's changed on the file itself, so we can certainly write it to another file called customer ids.csv as an example, right? So again, something that is a real world use case. Let's look at another example where we will remove all small case. This is a very simpler one. So you have a text where it's a mix of uppercase and lowercase. When we pipe it through tr, we just want to delete all the small case, so you're left with uppercase. If I was to replace this with a-z, you can see that now I'm left with ABC. So it's just a simple manipulation of these commands. So let's have another example where I have a sentence with a lot of junk in this file. You can see a lot of punctuation and different characters. I'm not interested, I just need to clean this up. So when I pipe it through tr, and what I'm doing is I'm deleting all the small case and the uppercase, but when I'm adding this -c, it's complementing that, so it's going to remove everything else except the letters. And when we run that, you can see there's a lot of junk in this file. So it's cleaned up that text. And if you just look at the man tr page, you can see that there are additional commands that you can use, like alphanumeric, alphabet, so all letters. You have blank, you have control characters. We looked at digit. You have graph, lower to upper, printable characters, punctuation, space, uppercase, X digit, and so on. So it's very powerful, and it does give you a lot of functionality. So I would encourage you to have a look at the man page as well. Let's look at another example. This is again an interesting one, where we have the echo path. So echo path on this system, and you can see it does print out, but it's not that readable. So let's make it a little readable. So let's pipe it through tr, and we're going to see we can see that the delimiter is a colon, so we want to replace that colon, and let's say give it a new line, and let's run that. And you can see again it's very readable now. And again, this is displaying on the console, but we can certainly write it out in a different file. Okay, let's have another look at another use case that has real world application. So we have this file called IP addresses. So we have a bunch of IP addresses, and you can see some of them have extra spaces. So let's clean this up as well. Let's see what is the command to do that. So we want to cat that IP address.txt, that file, and we want to pipe it through tr, and we are removing all the extra spaces, or using the -s. So you can see the result is a very clean output, and you've gotten rid of all the extra spaces that were in the original file. Again, if I look at the original file, it remains unchanged because we did not overwrite it, right? It just printed to the console. Let's look at another real-world example where we have the customer using credit cards, and we want to make sure that the credit card number is not displayed, it's hidden. So let's take a look at the example. So echo, please mask my credit card number, some random number. This is just 4 ones, 2222 333 404 for security reasons. So when we pipe it through tr and we look for digit, and all the digits we replace with an asterisk, right? So when we run this, you can see that I have successfully masked my or the customer's number. So this is great for security reasons. So we can also replace this character with another one, perhaps let's say, like, let's try to use this, and you can see that it does achieve the same objective, that it's masked your credit card number. Okay, there's also, you can use the tr for converting between DOS Windows formats to a Unix format, or vice versa, and also between Apple files, Apple formatted files, and DOS files. And again, you can use the tr command to achieve that. Let's look at another one, and then we'll give it a break. So let's see, I have another file where I'm reading this. I think we looked at some paragraph earlier. We want to look at the punctuation and just insert a new line. So as you can see, the original file was just in one line. So using this or running it through tr, we are able to make it more readable. And we can also add some like word count to tell us how many lines we have. So we have 7 lines in this file. So starting with the original file, which is if I show you, is just very unreadable, we're able to make it readable using tr. Okay, so just to cap it off, we will give a quick example of truncate, and hopefully this would be a useful tutorial for you. So let's take an example. So for truncate, we have echo infoverse, and we're piping it through tr. Now, as you can see, the set1 and set2 are not the same sizes. So set1 is larger than set2. So what this will do is that because they don't match in size, the last character of set2 will be used to complete the rest of the, or match it to info. So you can see that the in matched, and from starting with the first, which is 1, and then using the last character, which is 2, you replaced nfo with 222, and then vers is here, right? So this is how it's designed to work. So once you understand it, you know that if the set1 and set2 have a mismatch, then the set2 last character is used to fill in the missing characters. Let's look at another example where we actually use the -d, which is truncate command, and let's see how that works. So in this case, again, set1 and set2 do not match, but what the -d command will do is that it will make set1, which is this truncate, and be equal to the size of 1 2 and then do the transformation. So when we run that, you can see that it made it the same size as itself, so 1 2, and then the rest of the it's mapped as is. So that's all I wanted to show, and again, this is a quick introduction to the TR command. I find it very useful, and I shared some real world use cases. So I hope you found this useful and are able to also use TR in some of your own applications. So thank you for watching, and stay tuned, and don't forget to subscribe. Thank you.